Okay, so you can see the repository. As usual with these repositories, there is the README visible directly at the root of the repository, and it includes the installation instructions. There are two different, or actually three different ways. The last one you shouldn't use. There is an installation package, but it's quite old, and we maybe will update it one day, but it's a quite heavy process, so not doing it very often. So what I will go through today is the way to do it with Python and pipex. And this is a method that's useful when you just want to follow the stable releases. And then if you're a developer, then you're better off going from the source files to have the latest version. I think it's okay as a user also to use the source files. We try to, of course, avoid putting bugs there, but sometimes it happens. And of course, it also sometimes happens with the release versions. But the idea is to have a bit more cleaner versions in the pipex system. So then one thing here to note when starting this, if you don't have any Pythons and stuff in your machine yet, we are recommending at the moment that you should use 3.9 Python. It's not the Python that if you go to the Python download page, it's pushing you to get a 3.11. But if you go for 3.11, it will require also a version of this Microsoft Visual C++ build tools, which is a 1.5 gigabyte package. It's all doable. It's fine. You can do it, but it's just a bit easier to do it with 3.9. Also, we've just recently upgraded so that things work on 3.11, and there is maybe some chance that there is still something wrong because it is so recent. And also, I should say that currently the pipex version doesn't have 3.11 release. It only has 3.9 release. So that's why also if you're following the pipex, then you should do 3.9 at this moment. Of course, hopefully we will have it covered in near future, the 3.11. Also in the release versions. Right, so I'm not going to do this myself because it takes some time, of course, to do all the installation stuff. But just pointing that this link here is going to the 3.9 version, where the latest version where there is an Windows installer and also Mac, and I assume if you're doing Linux, you're probably going to be doing it from sources. So that's the instruction there. Then if you don't have Git in your machine, then you should also get that from the Git download site. And once all of those have been installed, Python and Git, then you can go to a terminal like Windows command prompt and try to run Python. If it doesn't find it, then it's for some reason not in path. Windows can, for instance, open a Windows Store and ask you to download Python, but of course you shouldn't do it because you have already gotten Python. So you just need to add the Python where it is in your computer to the path, and there's some instruction how to do that. You can do it from control panel by finding environmental variables from there, or then using command prompt to to add a new directory to the path. And of course, you should pay attention where these two tools were installed, so you can add them to path if it didn't go automatically. I had that issue with Windows 11 I tried today. I thought it should be automatic, but it wasn't. Then once Python works, you can just follow these. That should be pretty straightforward at that point. One issue is that Python, you might have not Python in your path, but you could have py in your path. That can also happen. Then you can use, instead of Python, just py. Right, going through this should install you the Spine Toolbox, and once that's done, you can then in the command prompt in the terminal just write Spine Toolbox, and it should open the interface to Spine Toolbox. And then whenever there is a new release, you can get the new release by writing this in the terminal, this upgrade command. Okay. And I think this is a little bit clumsy for regular users. So one of the things I think we should get done in Mopo is to really make this much easier, either having more regular updates on the installation file, or maybe having zip files you can just unzip and run, or maybe having a Docker or something, but something for us to work on. Okay, then I'm gonna go to the Spine Toolbox. Oh, maybe I just show here. I have a terminal, and I'm gonna run it with Python Spine Toolbox.py. Here is now an empty view. I will first open an existing project to show you some stuff with that. And it's not a Spine-opt project. It's a project for another tool, another modeling tool. And maybe it kind of shows you that it is quite flexible and can be used with many different kinds of tools. Tomorrow, then there will be more about Spine-opt. You can see here a workflow where there is input data on the left side, and then modeling a model here in the middle, and then you get results and you can plot and stuff like that. I will now just show you what's in here in the database that already contains input data. So I double click the database on the workflow, and I have this editor, Spine Database Editor view, where I can view the data and edit the data in several different ways, and I'll try to show you some of that. So one thing I can do is that I can filter things. I'm clicking this node here, and it filtered that it only shows parameters for nodes. And I could open this and click, let's say, one of the nodes and only see the parameters for that one node, the west node in this case. I can also use, let's say, control. I'm pressing control and choosing two things, one node and one commodity, and then I can see both of them at the same time. There is also this difference between objects here, and then the relationships, where relationships are, of course, kind of a where these objects have something that makes them related, and therefore some of the data can be on these relations instead of directly on the object. So here's an example of a unit input node where a water pump is tied to two different nodes, to a water source and a west node, and has some data for both of them. Right, and since we have these relationships in addition to objects, then it also means that this is a graph, kind of a data system, and I can also view the data as a graph. So now let's take, if I choose the units and I choose all the nodes, I can see how the units and nodes are connected. Oh, it's jumping around. And then I can maybe take commodities and the graph is updated to see the relations between the different things. And I can, from this graph, for instance, click the coal plant, and then it will filter all the parameters for the coal plant. But let's go back to the table view, where I just wanted to show you another way to filter is that the Toolbox databases can have data on the same parameter multiple times using what's called these alternatives. So I'm now choosing, let's say I'm choosing all the data, but I'm choosing the init alternative. So it shows only the data has been given for the init alternative. And if I choose, let's say, the west node, then I can also see data for the additional data that comes with the west alternative. Maybe a bit better example would be that I choose the wind. Where did actually, I should think where the sum of the data is actually changed between scenarios. These are kind of additional data and not really data changes. Well, let's not get stuck there, but yeah, I think it comes later when I show you other things then. Okay, sorry. Anyway, this is for filtering, and then I can also do data, show data and edit data by having them in pivot tables. So I'm choosing one pivot table type where I can show you how I can show different data, like here, that I have I should have more. Well, something is funny, but that's, well, at least you can see that we have time series data, and we have also constant data in the same pivot view, and could be edited. And I can move around the different dimensions, moving them from x-axis to y-axis, and also having them here as a filter. Okay. Then the next thing is that the databases can be purged. Like here, the workflow is such that all the data is in some original input files. So this is kind of a working database from which I can actually delete it because the data is still there in the workflow. So I will show you a purge of the data. There was a button here to purge. There is also a way to purge when you are in the database editor, but I will now choose here that I will delete all data from the database, and then I will also delete all scenario and alternative information from the database, but the data structure will remain. I'm not deleting everything. So after I've done this purge and I reopen the database, maybe I'll take the table view. You can see that there is no data anymore, but we still have the entity classes and the symbols and stuff like that here, and actually also all the parameter definitions are still there, but no data. Then I will make a new project in order to show how to import and export data. So in order to make a new project, I'm just gonna make a new folder first here. Let's call it demo and select that folder. And then that folder now becomes a Spine Toolbox project. And first thing I will do is that on this empty workflow, I'll drop a data connection. And let's name it input data. And then we need the importer to take the data from there. But actually, I forgot that we have to tell something what is this data, and I will add a reference to a file. I made a small Excel file for this purpose, test file here. You could have this test file in the project folder, and then it would be quite easy to wrap the whole project and send it with data. But in this case, it's not in the project folder. You could have it, for instance, on a cloud drive, so others can also access, or whatever way you want to work. So I'll have the input data, and I will connect that to the importer, and then I need somewhere where that importer is taking the data, so we will have the project database here. And this is now just empty. There is nothing here yet. I will first say that let's make an SQLite based database, and I'll give it a name, demo, and I click here, new Spine database, and it will create a new SQLite database with the structure of Spine database, but it's completely empty, of course, in other ways. And I will then connect the importer to the empty database, so there is nothing there. And then I will open the importer, and it knows there's an Excel file there, so it's suggesting that I will make an importer for an Excel file. And the Excel file has two sheets. Maybe I should just show the file so you know how it looks in Excel. There is a units sheet and time series sheet, and I will now make a specification for the importer how to import this into Spine database. So let's first take the units sheet. And first thing I want to do is that I am starting to define these mappings, how this sheet is mapped into Spine database. And I'm importing data that has actual parameter values. So I'm saying that it has values inside. It is actually they are not single value, not constants, because they are varying by period. So I'm saying that it's a map of values, and it's a one-dimensional map. There is one dimension of period, so we keep this as one, this dimensionality of the map. And that's now, I think, pretty much correct for this part. It can, of course, be edited if it didn't all go right. And then I will start to map the columns from the Excel. And first thing I do is that I say this object class name, I'm not taking it from the Excel. I'm just saying that the class name will be unit, but then the object names are coming from the first column. There's gas and coal, and I'm just writing one here, and it makes it maps the first column to be the object names. And actually, now I noticed that the first row doesn't have data, so I'm gonna skip that. So I'm gonna add the read data from row, make it 2. And another thing I'm not picking up from the sheet, but I write here, is that the parameter names are fuel price or is fuel price. And then the alternative names come from the second column, and the index names are now on the third column. And then, sorry, index name is not on the third. It's the name of the index is period, so it's just constant like this, and the parameter indexes come from the third column. And the parameter value are then on the last column, the fourth one. And as you can see, we need to tell the data type, and it kind of automatically tries to see what it should be. So they are now correct. They are strings, the first columns, 3 columns, and then we have a number floating point in the fourth column. And that's actually it for that first sheet. Let's make a demo importer's name for the specification, but let's also do the time series sheet where there is it's quite similar, but some small differences. One thing is that the parameter type is still value, and it's a map as well. The time dimension is on the first column, and now let's say that the object class name could be something like a profile, because these are wind and PV profiles. And the object names are now not coming from the columns, because they are in rows. There could be many columns of objects. So I'm gonna choose row here. The first row tells the object names, and then the first column tells the indexes, and then we need to give a name for the indexes, time, and also what we are still missing is a parameter name. That can be, let's say, profile. And then we also should give it a name for the alternatives, because the Excel sheet doesn't tell that, so they all belong to the same base alternative in this case. Now I think I've done the importer specification, and I'll try to run the importer. So I have chosen the importer. I'm executing a selection, you can click here or you can press F6. And then it all went fine, and we have now these two object classes and the objects or entities there with the data. So all of the data is in maps, so we don't directly see it here because they are not constants, but we can open the map and see inside. And let's say that we choose both of these, we can also plot the values for a quick look. Okay. So I'm now with this. We have now these 3 alternatives. Actually, there is always this base. I'm just going to remove it because we are not using it. So we have base, high price, low price, and alternatives, but we don't have any scenarios yet. So I'm now going to create a high price scenario, and that high price scenario will take base data and it will take high price data, and which means that it first chooses everything from base, and then if it takes from high price and overrides if it has something that was already in base. Otherwise, it just appends to the dataset. And actually, it's not overriding; it's making the choices in a way that it looks like it's overriding. I'll make another scenario, low price, the same system, writing here base, but taking the low price, and then I will let's make a small change as well, because I think I should also show you that I'm just changing the fuel price from 8 to 9 here, and now we've done changes to the database, but they have not yet been committed. So you need to commit your changes and write a commit message, hopefully something informative. You can do it from the menu here, but you can also press Control Enter to make a commit message. So added scenarios, changed fuel price, coal price. Right. Then I'll close the database and I'll go to the exporter. A very boring name, but let's then write to CSV files, for instance. We can call this results, although we are not doing any changes. We are just passing stuff through here. But I probably need to make the text file first. I haven't done it yet. Text file. Right, so I just made a text file in the background, but now there is a results.csv, and I'll hook up the database first to the exporter and then to the file. And now we of course need to define the export. So
By the way,
is interface for the exporter. And
hey.
again, we are doing mappings, but now we don't have sheets from which we are doing. We have the database, so we can do however many mappings we want from that database. Let's first do that fuel price mapping. And
Hey,
for this to work, we start. I'll put the preview on. It can be a bit slow, so I often it's good to have it.
Juha, can you hear us?
Yes.
Because I think Antti is trying to say something.
Yeah,
Okay.
can you hear me?
Yeah, I can hear you now.
Yeah, I was just going to ask that, are you sure that data connection is needed there? Because exporter will get its file name from its properties.
Oh, sorry. You're right.
Yeah.
You're right. You're right. I was just doing a mirror without thinking. Sorry. So this is not needed because it will, you're right, it will just based on the output file name, once we define that this is, let's give it a name. Is this one? I don't know. Okay, and the file name was gonna come from where? There's this one, so yeah, it's just taking it from the database now. Why I'm having this? Somehow I made two specifications. That was not smart. I hope we are now working on the right one. Yes. So I want to export parameters, and from the units table, I'm putting the live preview on. You can see that there is stuff it would already want to export, but that's not the right format. So I will start to edit it. First, I will make a filter so that I'm only going to be exporting units, and this filter uses regex, regular expressions. So I could just write unit and it would work, but I put the additional things here to make sure that if I have more stuff there, it will not take unit class, for instance, here in the filter. I want to have a header row, so unit, and then I'm filtering only the fuel price parameter, and let's say that we want, no, wait a minute, I don't want to actually export those object classes. I'm gonna hide them because we only want to export the objects themselves. We're gonna put it in the first column, and then the parameter definition can go to the second column. We can call it param name, and alternatives then third row, and then let's do it so that we will add one dimension, because this is this parameter has a dimension, single dimension, and we want to put the parameter indexes. Let's then pivot that to put it in a row. And now we start to see the actual data inside the map, because the mapping has enough dimensions to actually show the data. And it automatically says that the parameter values are now in the pivot when we have both rows and columns in the mapping. We have pivoted data. Probably we should also have a header for this. So that's one exporter, and we could do similar exporters for the time series data, but I don't think that now serves a purpose. We could also say that the file name should come from here. Sorry, fuel prices. So we have an exporter, and then if I run the exporter, I was pressing F6 to run only the exporter. And then we can see that there is this file which it fails to open.
Do you have a editor set for CSV files?
Let's change this to
Okay, so it's a bug.
now it opens. So it did something, but it didn't quite actually do what I was asking it to do. So there is something, because the 2020 is missing. But maybe it's a problem because CSV files are not supposed to be pivoted. Let's try. I'll change this to Excel. It still looks the same. And if I now run this, it writes an Excel file, which I click and then get it open. Well, still something wrong. We have to look into this. But I think it's still enough to demonstrate the principle. One thing here I could also do is that now I have multiple scenarios selected. I guess it's maybe actually this. If I don't select any, it probably then writes as it should run. Yeah. So in this case, in the previous case, we didn't have the data set up in a right way. I mean, you shouldn't be using scenarios in that way with an exporter. So now it works when it was set the right way. All right. Then did I have something else? Yeah, another thing is to add tools to the workflow. So there is some tools that are plugins in the Spine Toolbox. So there is a manage plugins here. I can remove and add and update plugins. And then I can drag plugins from the toolbar. And when I take something like this, there is pre-made definitions inside, a specification for the tool that defines how it should find the tool and run it. And in this case, it's very simple. You should point a valid SpineOpt database to the tool before it makes sense, but in principle, it's quite straightforward. And you can, of course, make your own tool specifications. So I could drag an empty tool here and could call it something, and then point it to a, let's say, Python tool that does something with the data and passes it on, stuff like that. Let's take this out of the workflow. And then, of course, I could run the whole workflow by pressing run on the whole project. I think that was all I had in my list of things to show. But if there is any questions or any suggestions from colleagues who know what more I should show, all of that is welcome.
One thing that came to my mind was this compact button in exporter that would have been handy for you, since you removed the first column and then moved the other columns one step to the left. In the center down bottom, there is the compact button. Yeah, it removes empty columns from the.
So if I would have.
So if you would, and then click compact.
Okay.
That's
I didn't even know that.
Yeah, I'm guessing people don't really see the button there, but yeah, it exists and it's sometimes quite handy, I guess.
Omar.
Yeah, I have a question. Just all those things that you can do, is there also documentation how to do it in not using this GUI, but using just making a script? If you want to integrate the information, the data, or the tools that are in Spine and in your own script, that I imagine there's documentation for that as well.
Yeah, in what condition the documentation, Antti or Manuel, can you?
So, but we have the headless execution mode that you can use to run programmatically a project that you have created with Spine Toolbox using the user interface. But you have to go through this design view to create the project in the first place. There's no way to programmatically create or build a project at the moment. And that might be something we want to develop in the Mopo project, I think. So I don't know if that's your
yeah,
question.
I mean, I'm trying to figure out what I would do with this here, but maybe I need to. But it's just there's data available, there's tools available, and yeah, sure, you can use a GUI to do that, but maybe you want access to some data. I mean, I imagine it's possible to access it just by writing a script. I mean, if you import the library to read things and then.
Yeah. That's it. That's fully possible because all the interaction with the data and with the database is managed by this package we call SpineDB API. That's in the Spine Tools repository, and the documentation is minimal, I would say. We have.
Okay, but it's possible to do it. So then
we do it all the time. Yeah.
Yeah,
from
okay,
a script,
thanks.
from a Python script, you just call some functions to read the database and then do some manipulation. From Julia, you have also an API to do that. So it's possible.
But there's a Python API, and that's enough for me.
Yeah.
And I mean, these exporters and importers, while they can do nice things already, I think I know for sure they don't cover all use cases you might have for how you need to transform your data. So it is often that you would need to do some code using the Spine Database API or using the Julia Spine interface. for making those data manipulations. Of course, in Mopo project, we want to make these importers and exporters more capable. So most stuff people might need to do could be covered here with an interface, and also in a way that it would help people to maintain the versions so that when the data changes or the tools change, you can maintain a working data transformer between those different versions of tools and data.
Maybe if I could just suggest, in tomorrow's Spine Opt demonstration, Manuel will also be briefly demonstrating Spine Interface, which is like a Julia wrapper for the Python API, let's say. And it is actually very nice for doing exactly what you're suggesting. And in Python and Julia, it's quite straightforward, and I'm not a particularly accomplished coder and have managed to use it myself. So it's as simple as, you know, creating dicts of the relationships and objects and parameter values, etc. that you want. So it's quite easy to follow. But anyway, you might find it interesting, the demonstration tomorrow.
Yeah, thanks. I will be there.
Hi, Yo. I think there's a question in the chat about alternative names.
All right, thanks. Sorry, I didn't any more followed. So yeah, we can actually, you can load files from, you can load stuff from different files. So I could have multiple Excel files here that would go into one database, and you can even choose then what is the order of writing. So here is this number 1. It's the first one, but of course now there's only one. But if you have multiple channels of input, you could choose in which order they execute, and that's why you could have a data coming like you have a base data set in one Excel and then additional data in other Excels or whatever is your data source, and then also it's possible to have multiple databases, and you can see the contents of multiple databases in single database editor view. That's also possible.
And this, I should say, maybe that this is like a demonstration of the basic functionality, but we have a lot more functionality, I would say. Like, for example, looping. We can have workflows that loop back to a specific item, and then you can have a condition to terminate the loop. We also have the view item where you can have like a static or a reference to a parameter value that you can then plot every time you run your tool. So you can actually see the plot changing as you modify your input data, for example. And probably some other stuff I don't remember. So to create loops, you need to press the Alt key before creating the arrow. And that's, yeah, it's a little bit advanced at the moment, since you basically need to write a script and collect data from, I don't know, the input data or for example, the result of this exporter is available. So you can, based on the result of the importer, sorry, of the exporter, you can write your termination condition. It's yeah, it's not the first feature you will use, but it's there and it's quite powerful. We use it. We actually have a workflow with 3 nested loops. Sorry, just saying.
Right.
And maybe just briefly on that, the merger tool is quite useful as well, particularly in this kind of workflow. We find ourselves using it a lot where we have a similar workflow as you has showing here with an Excel file, some input data, an importer that creates a database, and that's going to, purge that project data store every time because it's refreshing it from the input data. But you might also want some sort of static data that gets added on top of that you don't want purged every time the project runs. And so that's typically, we often set our projects up this way where we have some, let's say, programmatically created data that is in project data that gets regenerated every time, but then some static data that kind of gets added in on top of that each time, and that might supersede some of the data or add to the data. And there's an awful lot you can do with the alternatives and scenarios and stuff like that.
Yeah, try to do something like that. Okay. Oh, there's a question now. Is it possible to iterate over files inside a directory instead of manually connecting them to the importer individually? I can add multiple files from the dialog at one go, but I don't. There is no iteration as such, I think. And then once there's files selected, I can. It's actually here. I can, if there would be multiple files, I can choose which one I'm actually importing this time.
The data connection actually monitors its own directory. So if you add more files into this, if you click the data connection there is this data list. So you can, if you add all files there in that the directory this guy is pointing to, they will be automatically included in the data connections outputs.
But I think it's a good point to, we have this arbitrary executable tool that we can include in our projects. And I mean, similar to what's been just discussed, you can use the Python or Julia APIs to do whatever you want. So you could just write a simple script that will iterate through files in a folder, for example, do something with them and write to a database. So yeah, you always have the option to complement the existing workflow tools with your own custom scripts using those tools. Yeah, it could be executables, Python or Julia.
Yeah, and that kind of answers the additional question that would be useful to be able to filter files, let's say with regular expressions, and of course what Jody just said, we'll cover that case. You make your own script for that. So when I pull a tool here, I can, in the tool specifications, I can say which type it is, Julia, Python, GAMS, executable at the moment. All right, we are at the end of the time. Thanks for your attention, and see you tomorrow, and especially next week. Bye-bye.
Thank you, Johan. Bye-bye.